Hello, my name is Walter Unglob, and this is How Tension Reacts with Weight in Physics. If we consider a simple scenario where we have a ceiling and a rope attached to the ceiling, and at the end of the rope we have some box of mass m, and the box remains at this height away from the ground, then we can consider the free body diagram for this physical scenario in which we reduce this box to a point mass m, and we draw the vectors associated with the various forces acting on the mass. So here we have two forces. One is a tension force, and the other is the force of gravity that's acting on the box, trying to pull it down. But because the mass is not accelerating, and initially it wasn't moving, it's going to remain here. And that implies that because the directions of these arrows are 180 degrees apart from each other, that the magnitudes must be the same. So, using Newton's second law, we have the sum of forces is equal to mass times acceleration. So in this case, there's a total of two forces, and we have zero acceleration on the right-hand side for this equation. And for the sum of the forces, we'll have, if I choose the y direction going up to be positive, it doesn't matter as long as one is consistent throughout the calculations, we have the tension force plus the gravitational force is equal to 0. Now, of course, if I'm interested in the magnitudes, then I have to factor in or take into account the fact that the gravitational force is acting opposite to the tension force. So I have the magnitude of the tension force minus the magnitude of the gravitational force is equal to 0. Therefore, the magnitude of the tension force, which I'll just refer to as T without the arrow on top, is equal to the magnitude of the gravitational force. If I just move this over to the other side, the gravitational force is equal to the mass of the box times the gravitational acceleration. Therefore, the tension is equal to mg, and mg is the weight of the box, because the mass of the box does not change regardless of where it is in the universe. But the weight, of course, does depend on where the box is in the universe. In this case, it's on Earth, where we're considering g as the gravitational acceleration. So this value would change if we were on a different planet, for example, with a different mass. And finally, this is the relationship between tension and the weight of the box in this simple physical scenario. My name is Walter Unglob, and this is How Tension Reacts with Weight in Physics.